Hello friends, so we are solving this question jump game second, which is similar to our previous question which we have solved previously, jump game 1. So the difference between that and this question is like in that question we need to return true or false on the basis of whether we are able to reach to the last index from the initial index, and in this question we need to find the minimum number of jumps that we will be requiring to move from first index to the last index. So what is given in this question is like we are given an array of integer nums of size n. We are initially at position 0, that at num 0, and each element num I represent the maximum length of the forward jump that we can take from index I. In other words, if you are at num I, you can jump to any num I plus j where. Okay, so if I am standing at any index like num I can take jump from 0 to that num I. So the j, for example, we consider 2 so it will be in the range from 0 to num I. So we need to return the minimum number of jumps to reach to the end, and it is also given the test cases are generated such that you will reach to the end of the array. So like all the test cases which are given for this question will contain at least one path that will help us to reach from starting to end. So like taking the look of this question, so like what we are having here is so we are considering the like this from 0 index maximum we can take jump is 2. So from here maximum jump I can take is 2. So I can be at this position or I can be at this position. Like from here I can be at this position, or from here I can be at this position. So like standing at the 0 index, maximum jump we can take is 2. So what range it is opening for us? It is opening the range of this 2. The range open from 0 index is this 2, so we are at this range. So like okay, now from here we can take in this range we are here. So for jump 1 we are in this range, and now in this range, from this range we can either choose 3 or either we can choose 1. Both will help us to reach to the next range from 3, like 3 from current index which is 1, and our maximum jump we can take is 3. So from this first index, what range, maximum range we can open is 4. So from here the maximum range which will be open for us is this. So and this range contains a last element, so this will be a required solution. Like from in first jump we are reaching to a one range, and from second jump we are reaching to another range. So another range contain a last element or the last index. So this is a required solution. Like in two jumps we are able to reach to the range which is having a last index, but we need to encounter or we need to check for each element in that range. So like in this case 1, if we are not going to first index from 0 index, we are directly moving to 1. So from here we can take one jump, and then from here we can again take one jump. So in this case also we are able to move to the end of the array. But the catch here in this question is like we don't have to say whether we are able to move to the last element, but whether we need to give the minimum number of jumps that we are required to move to the last element. So like let's say 0 index, 1 index, 2 index, 3 index, and 4th index. So standing at 0 index I am able to open the range of 3 and 1, and from this I am able to open the range of this. So like in two jumps in two jumps where in both jumps I will be able to open a new range, I am able to move to the end of the array, that is a last or required desired position. So so like okay, so we can have a variable first of all let's dive deep. From 2 I am having 2. So from here I can reach to 3 1, or I can reach to 1. From 3 I can reach to first index, I can reach to second one, or I can directly reach to fourth one. From 2 I will reach to 1, then from 1 then 1. From 2 I will can reach to 1, then okay, from 2 I reach to 1, then 1, then 4 I can reach. From 3, from 2 to 3, 3 to 1, then again 1 I can go, then from here 4 I can go. From 3 this 1 I can go, then directly 4 I can go. So there are different path through which we can reach to the end of the element, end of the array, but we need to find the minimum, and what we are getting minimum is here, this from 2 to 3 to 4. So here what we can use, it is forming a tree like structure. So what we can use, either we can use a recursive approach or we can use a dynamic programming approach, but these two approach are not optimal for this question, because both these approach will take time of capital O of n square. So we need to find a more optimal approach. In this case we can use greedy approach that will only take capital O of n time. So how we can use this greedy approach and how it will resolve our problem in linear time complexity, that we will look. So now look, we are at current index. We will iterate this nums as a from last to end through a variable I. So our I variable currently at index 0. So first of all we need to maintain the range, like I am standing at current index and using that index value, what range I am able to open, so that we will store in our variable range. So current we will initiate range to 0, and now what is the maximum index which is available for this range? So we will have another variable like max index. So it will indicate the maximum index that this range will have. So like okay, so consider this scenario like I am at 0 index. So a range, and okay, one thing, what range will be there, what range we will consider. So range will be considered the maximum of current range that we are having, and from current index number of jumps, while taking number of jumps, what index I can, or what the maximum range I can reach. So this will be our calculation for range. Okay, so now consider like range we are having initiating from 0 and maximum from 0. Now again one more variable to have number of jumps. Initially we will have 0 jump, and consider, keep this in mind, like every while opening a new range we will have to take a jump. Like from 2, if we are going into this range, then we will take a one jump, and from this range if we are moving to another range, then again we will take that jump. So range, what range, maximum range we will have will be maintained in this variable, and what maximum index of that range will be maintained in this variable, because every time when we are reaching to the like last element of our current range, that will be indicated by maximum range, then we will have to take a jump. So in that case we will increase our jump variable by 1. So okay, now let's dry run this and see like what actual will happen. So currently range is 0 and currently we are at 0 index, so 0, and what maximum we can take is 2, so 2 we can reach. So our range will change to 2. Now we will check if our current index like I value is equals to maximum index. Like maximum index will have the index of maximum, like last element of the current range, last index of the current range. So like it will check like we are traversing from 0 to end, so whether we have reached to the end of the current range. If we have reached, then we have to jump, we have to move to the next range. So in that case we will increment the value of jump by 1. So the current index is maximum index is 0, so we will change this max index to current range. Like current range is 2, so like maximum we can reach is 2 second index, so maximum index will be changed to 2. Now again we'll move, I will move to next index. Now it will again check the current range is 2, I value is 1, and from like maximum length we can, I can take from here is 3, so it will be 4. So now maximum of these two from 2 and 4 is 4, so our range will change to 4. Now okay, now again, so first when we, oh, so in the previous case when we have changed our maximum index, then we will change our jump variable to 1, because we have moved in next range, so we have taken a jump, that is why we have moved to next range. Now I will increment again, so I will be incremented. Now again it will check, like maximum range value is 4 and current index is 2, and I value is maximum jump we can take is 1, so it is 3. So it is not maximum from current range, so nothing will change in range. Now maximum index is 2, so like we have reached here, so like we have reached to the end of our current range. Now what we have to do, again we have to change our range. So while changing range, a jump, we will have to take a jump, so jump will be 2 and maximum index or will be changed to our current range, that is 4. Now we will check if we have like maximum index is greater than or equals to our last index, then in this case we will return the number of jumps. So this would be our answer. So like in this case only, if now we will again, so this would be our answer. So what we are basically doing is we are finding the range and we are having a flag variable like maximum index, that is telling us that yes, we have reached to the maximum index of our current range. So we have to make a jump and take a jump, and then from that next range find the maximum which will helps to reach to the end of the array or the last index to get us required solution. So this we are doing. So now we will implement this solution, or like one again I am telling, like from 2, the maximum range which we can able to open is this, and from this range we are able to open the maximum of this range. So maximum this range, and in second range we are able to find a solution. So we need to check the range and the last index of that range. So now we will implement the solution. So first we will uh, have this variable place. Initially jumps are 0, then int what we are range is also 0, then int maximum jumps, so we can take maximum I and index is equals to 0. Now we can also have a variable int and where we will store the size of current array. Okay, now the base case is when n equals to, or we are having only one element. So like from starting and last index are same, so no jump will be required. So our base case will be this. We need to handle that if n is equals to 1, then return 0. Now for other than base case, we need to iterate the whole array one time. So int I is equals to 0 up till last index I is equals to n I plus plus. So first of all what we are doing, every time we are at any index we are first calculating the range from this element, the maximum range which we can get. So we will do the same. So range, maximum of range, and from current index maximum length of jump we can take is that num size. So between these two, whatever the maximum would be there will be our current range. So now we have calculated a range. Now every time we need to check, like I is incrementing in each iteration, so we need to check if whether we have exhausted our current range limit. So we need to check that if I is equals to max index, if it is there, then we need to update the max index is equals to range. And now what we have seen, we have exhausted our current range, so we are moving to next range. So every time we have to move, we have to take a jump, so we will increase jumps variable by 1. So we can include post increment operator here. Now we have moved to other range, we have incremented the jump. Now when I have moved from this range to this range, now I can check if my maximum range, like maximum range in this category was 4, so I can check if my maximum range is greater than or equals to my current size or the last index. In that case I will return the jump because that is what we desire. So this we will return a number of jumps, and in the end also we will return jumps. Okay, so this is our required solution. First let's run this. Okay, so this is accepted. Let's submit this question. So yes, it is submitted successfully. Now the time complexity. So as we are iterating this nums array one time from 0 to end, so its time complexity will be capital O of n, where n is the size of this nums array. So this is our required solution. Thank you for watching.